Glider 3.1 Aerodynamics of Flight. As we embark on our exploration of the aerodynamics of flight, let's unravel the fundamental principles that govern the soaring journey of gliders. To comprehend the essence of glider flight, pilots must first grasp the intricacies of aircraft aerodynamics, the ballet of forces that orchestrates takeoffs, maneuvers, and landings with finesse. This chapter serves as our guide to the aerodynamic ballet, shedding light on the forces at play in their intricate choreography. In the realm of flight, four forces gracefully waltz upon the stage during straight and level performance: lift, gravity, thrust, and drag. Lift, the ethereal partner, dances in harmonious opposition to gravity, while drag pirouettes in tandem with thrust. As these forces execute their choreography, achieving equilibrium bestows the gift of sustained straight and level flight. For our engine-powered gliders, thrust emanates from the engine, becoming the maestro orchestrating the symphony of forces. Once our glider takes flight, whether by engine power, launch, tow, or winch, the symphony persists. The glider's ceaseless descent becomes a dance with gravity, transforming potential energy into kinetic energy, akin to a gravity-infused forward thrust. The stage is set. Gravity, the silent conductor, guides the glider's descent rate, intertwining height with distance in a gravity-induced duet. Let's illuminate this dance further through our visual representation of an unpowered glider in equilibrium. Here, the lift vector elegantly splits, with one component defying gravity, the other opposing drag by transmuting potential energy into kinetic energy, a spectacle of forces in perfect balance. Newton's third law of motion, our guiding principle, unveils the dance of action and reaction. The air, dutifully deflecting downward, begets an uplifting reaction. The wing, a crafted instrument, manipulates physical laws to extract two actions from the air mass: a positive pressure lifting action beneath and a negative pressure lifting action above. Venturing deeper into the artistry of flight, lift becomes our focal point. Acting as the counterforce to gravity, lift is the progeny of the dynamic ballet between the wing and the surrounding airstream. Behold, the equation's poetic dance: lift's intimate relation to airspeed square, the angle of attack's sway, air density's embrace, and the wing's expansive grace. Doubling airspeed quadruples lift's allure, while shifts in angle of attack, air density, or wing size enthrall us with their own captivating nuances. As we traverse the skies, understanding lift's capricious dance with these factors becomes our compass, guiding us through the intricate symphony of glider flight. The journey continues, with each chapter unraveling new layers of the aerodynamic ballet, propelling us further into the realm of soaring mastery. In the intricate realm of glider flight, the force known as drag emerges as a silent partner, resisting the glider's passage through the air. Like a complex symphony, two distinct types of drag, parasite and induced, converge to shape the intricate dynamics of total drag. While the intricacies of these drag forces are further detailed in the Pilot's Handbook of Aeronautical Knowledge, FAAH 8083-25, let us gracefully traverse the realm of drag in broad strokes. Parasite drag, my esteemed aviators, embodies the resistance encountered by any entity traversing the air. Although the glider's wings boast minimal parasite drag individually, the collective drag of the entire glider becomes consequential, especially at elevated speeds. In this aerodrama, parasite drag manifests in three acts: form drag, skin friction, and interference drag. Notably, form drag arises from the turbulent wake formed by airflow separation, a force alleviated through streamlining. Now, let's delve into the dynamics of this intricate interplay. Form drag, the opening act, unfolds as the glider pushes air aside, creating pressure differentials that result in an opposing force. To reduce this force, one can minimize the cross-sectional area or streamline the glider's form, optimizing its posture for optimal movement. As we transition to the second act, skin friction drag takes center stage. An invisible ballet of roughness on the glider's surfaces gives rise to skin friction drag. Despite seemingly smooth surfaces, microscopic irregularities create eddies and low-pressure areas, contributing to drag. The boundary layer, a decelerated air realm, plays a pivotal role. The reduction of the wing's surface area diminishes skin friction, enhancing the overall performance of our soaring partner. Within the boundary layer, where air experiences deceleration, two distinct forms emerge: laminar and turbulent. The laminar boundary layer epitomizes smooth, gliding layers of air, while turbulent counterparts are adorned with eddies and irregular flows, generating additional skin friction drag. Designers strive for laminar flow, reducing drag and optimizing glider efficiency. Enter the turbulator, our third act maestro, a thin zigzag strip strategically positioned beneath the wing or on the fin. This aerial choreographer introduces turbulence, delaying separation and augmenting energy within the turbulent boundary layer. The result: enhanced gliding efficiency. Yet, challenges arise in this interplay, such as the separation point, where the boundary layer breaks away due to pressure gradients, fostering bubbles of stagnant air. Ingenious shaping of the airfoil or the addition of turbulators mitigates these challenges, maintaining laminar flow and reducing skin friction. Nature, in its capricious performance, introduces external perturbations. Rain, ice, insects, and dust, though minuscule, possess the power to induce turbulence, necessitating vigilant wing maintenance to prevent premature transitions and unwarranted increases in drag. In this fluid interplay of drag, the glider and its aerodynamic elements, like performers on an aerial stage, weave a tapestry of forces and counterforces, each movement shaping the trajectory of soaring grace. The drama continues, and with each revelation, the glider pilot gains a deeper appreciation for the nuances of this celestial performance. Given picture provides us with a visual representation of the intricate relationship between drag and speed, revealing how Parasite drag amplifies with the square of speed. And as we gracefully turn the page, we witness the ethereal streamlining of airfoil designs, greatly reducing form drag by minimizing airflow separation, an insightful testament to the elegance of aerodynamic optimization. The turbulent boundary layer, dominated by eddies and irregular flows, unveils the complexities inherent in the glider's quest for optimal performance. Our eyes then fixate on where the impact of turbulent boundary layers on skin friction becomes evident. Our final visual aid presents a captivating ensemble of challenges: raindrops, insects, and dust, all capable of inducing turbulence. This visual narrative accentuates the importance of meticulous wing maintenance to preserve laminar flow and mitigate unwarranted increases in drag. And there we have it, my esteemed aviators, a panoramic view of the intricate interplay between the glider and drag, each figure and visual aiding our comprehension of this celestial performance. As we proceed in our academic flight, let these visuals serve as beacons, illuminating the intricacies of the dance between the glider and the forces that shape its graceful trajectory. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.